Welcome. Time value of money. This is Appendix C. This is in the back of your textbook. It's not the chapter Appendix C in Chapter 10, but it's all the way in the back of your textbook after the last chapter. Appendix C, the time value of money. This is an amazing chapter. It will help you plan your retirement someday. If we do a retirement lab, you will use these calculations. Also, if you think back to the bond chapter, how we came up with those bond selling prices. The textbook just gives you the bond selling price. Maybe you sold a bond at face value, 100. Maybe you sold a bond at premium, 102, 104, or maybe you sold a bond at discount, less than 100%, 98, 97. This chapter, along with other areas, will help you understand and calculate that bond selling price. Time value of money. What is it all about? The same amount of money, $50, is worth more today than in the future. Now why is that? Why do we say that? If you took that $50 and invested it and you earned interest on it, it will be worth more in the future because you had the opportunity to earn interest on it. Of course, if you take your $50 and you put it under your bed, under your mattress, and you take it out in 3 years, it will still be $50. It won't earn interest. But we're not really talking about the face value just. We're talking about the value, the buying power of that $50. So how do we calculate interest when we have an amount of money and we're going to earn interest on it? There are two ways to calculate interest, the easy way and the more complicated way. And guess what? We're doing the more complicated way. But let's start with the easy way for comparison purposes. Simple interest. You borrow $5,000 today. You use it for something. At the end of 2 years, you pay it back plus 12% interest. Now, I want you to get into your head whenever we quote interest rates, it is always based on an annual rate. So when I say I'm going to borrow money for 2 years, I'm going to pay 12% interest for 2 years, for each of 2 years. So if we were just doing simple interest, we would take $5,000 times 12%. So put that into your calculators and you will get $600. Again, using simple interest, we would again take $5,000 for the second year and multiply it by 12% and get another $600. Now this actually is the tricky part. At the end of 2 years, what do you pay back? What do you owe? And oftentimes students will say, well, I owe $1,200. No, you owe $1,200 plus your beginning balance. You owe $6,200. So let's practice. You guys come up with this one. I'll give you a sec to do this. All right. So again, simple interest, 9% a year, $90 the first year, $90 the second year, $90 the third year. You owe $270. Interest plus your principal is $1,270. But of course, we're not going to do simple interest. And honestly, simple interest doesn't make sense. So we're going to do compound interest. And compound interest assumes that you are not paying the money back each year. Nor are you paying the interest each year, but the interest is growing. So you borrow $1,000 for 3 years at 9%, and you would say, how much do we owe at the end of the first year? Well, of course, that would still be $90 for the first year. But the second year, you've essentially borrowed the $1,000 plus the interest that you have not paid yet. So when you apply that 9%, you're going to apply it not against $1,000, but against $1,090. You're going to calculate interest on that, and you're going to get $98.10 for the second year. For the third year, you add the $98.10, you add that to your beginning opening balance of 1,090 and you have 1188.10, and that's what you are borrowing the third year, and that's 106.93. So you can see the progression from $90 to 106.93 because of compound interest. So these interest amounts are going to grow because essentially you are borrowing more each year until you pay the loan back. So you're going to pay $295 on interest with compound interest. Compare that to the $270 that you paid. So at the end of 3 years, you're going to pay back $1,295.03. Why do you have to do that? Because you haven't paid this 90 back the first year. So you're essentially borrowing it for the second year. The second year you're going to owe 98. The third year you haven't paid the 98 or the 90 back. So that is what you're borrowing the third year. And that is why it is called compound interest. Another name for that is interest on interest. Let's do the same example using the tables. So for present value, you use the tables or you can use your calculator. Some students prefer to use the math formula. We use the tables a lot for this class, so I want you to at least be familiar with them. So if you use the tables, you would turn to the back of your book and you would say, I'm going to look at what table? So we have to find the intersection. We're going to look at table 1, and it's on page C4 at the back of your book. And you're going to say, I know the interest rate, 9%. You can see that across the top row. I know the number of periods. The number of periods are 3 years. And for this example, we're only calculating interest once a year. If I were to calculate interest twice a year, my N would be 6 because it would be 2 times a year. But I'd also have to change my interest rate to 4.5%. But let's keep it simple. We are going to calculate interest annually. So you'd look for the intersection, 9%, N equals 3. And you'd look on table 1 and you would find the factor. We call this number a factor, 1.29503. And we will take that factor and we will multiply it by our present value. Now as you approach these problems, I want you to lay out all these variables. And so we are solving in this problem future for future value. And that's why I started off with a question mark there. We knew present value, we knew the interest rate, we knew the number of years. And when you read the question, what will it be worth in 3 years? That tells you it's a future value problem. And it's a single amount, it's only $1,000, so we're going to use table 1. And I always also like to lay out a timeline. Sometimes I think that's just easier. So Grandma gave your parents $20,000 when you were born for college 18 years later. What is the future value of $20,000? So wouldn't that be nice if 18 years ago somebody opened an account for you, $20,000. If we assume you're earning an average of 6% a year, it's 18 years later. We don't know future value. That's what we're solving for. So we know we're going to use table 1 because it's a single amount. Table 2 is also future value, but it's for an annuity. We're not doing an annuity here. So go to 18 years, 6%, and you want to get that factor there. 18 years, 6%, the factor is 2.85434. Multiply that by 20,000, you would have $57,000 today to put towards your college education. Not bad. And let me say right now, that same argument would work toward your retirements if you put money aside today and didn't take it out for 18 or 20 or 30 years. So let's move on. We're going to look at the next table at the back of Appendix C, Table 2 on page C6. Annuities. What in the world are annuities? What do you guys think of when you think of an annuity? Maybe you haven't heard that term before. It's a set of they have to be exactly equal dollar amounts that are paid out or received. For example, let's say you're 60 years old and you have all your money in CDs, certificates of deposits, a type of savings account, and one particular CD has $1,000 and it pays 6% interest per year, or $60 a year. The $60 is your annuity. Okay, another example. You buy a car and your payments are $350 each month. The $350 are your annuity. Or you could say you're buying a house and your payments are $1,000 or $1,500 a month. Let's say you are saving money because you want to go to France after you graduate from the university. So every year you put $1,000 into an interest-bearing bank account on December 31st. You're going to do that every year for 3 years. 2011, 2012, 2013. At the end of those 3 years, what is it worth? So we're going to have some examples here using calculating future value of an annuity. Now again, I like to show the timeline because I think I think people work better with some sort of a picture. But you can see I've got all my variables here. A company, every year at the end of the year, they set $25,000 aside because they know in about 4 years they want to buy a new printing press. So this company does their own printing. At the end of year 4, right after they put their last $25,000 in, what will the balance be in this account? So the first $25,000 is going to earn 1, 2, 3 years of interest. The second $25,000 is going to earn 2 years of interest. The third $25,000 is going to earn 1 year of interest. And the last $25,000 is not going to earn any interest. This is called an ordinary annuity. Our interest rate is 6%. Now, we want to know future value. But when you have a payment problem, present value is NA, not applicable. So we only focus on the future value, which is what we're solving for, and the payment amount, interest rate, and the 4 years. So look up that factor on table 2. Interest rate 6%, 4 years, and that factor is 4.37462. We multiply it by the 25,000, not 100,000, just the individual annuity amount. And at the end of 4 years, you'll have 109,365. If you had taken that same 25,000 and put it under your bed, you'd have 100,000. So you can see you earned about $9,300 in interest.